Hello, I'm Funako. Today, let's try solve lowest common ancestor in binary search tree. Let's check problem sentence. Given a binary search tree where all node values are unique, and two nodes from the tree P and Q return the lowest common ancestor of the two nodes. What is lowest common ancestor? Yeah, the lowest common ancestor between two nodes, P and Q, is the lowest node in a tree T such that both P and Q are descendants. The ancestor is allowed to be descendant of itself. So example 1, 5 is root node and P is 3. So P and Q is 8, Q. In this case, the lowest common ancestor is 5. Mhm. And we can find root node is always uh, ancestor of each node because this is root. So if P is 2 and Q is 9, uh, ancestor is 5. If P is 1 and Q is 8, the common ancestor is 5. So always this is the candidate of ancestors. But if P is 1 and Q is 4, in this case, the lowest ancestor is 3. So maybe we can realize split when split occurs, then that current node is lowest common ancestors. One more example. Uh, P is 7, Q is 9. In this case, first, uh, current node is 8. Current node. Then split occurs. P is left, Q is right. Then current node is lowest common ancestors. Okay, so let's think about. Oh, sorry. Mhm. Okay, this is called. Mm, so, ah, we have to think about this is binary search tree. So, binary search tree's condition is greater value is right, less value is left. So, this condition, mm, this condition is the key of solving this problem. So first, uh, and if we find if we find P or Q, uh, if we find P or Q, we return, uh, we can return the lowest common ancestor. For example, so P is P is this root node, and Q is 8. Mm, in this case, the current node is 5, and 8 is Q. Mm, in this case, P is the lowest common ancestor. Uh, sorry, I forgot to start to stopwatch. So, 10 minutes start. And we can think, mm, if P and Q, P is 7 and Q is 9. First current node is 5, but P and Q both node is greater than current node. So we can verify next node is 8. 8 in this node, this is current node. Then P is less than current node, so left. Q is greater than current node 8, so right. Then split occurs, so lowest common ancestor is current node. Mm, if both node P and Q is both, mm, so for example, P is 1, Q is 4. Both node is less than current node, so we verify, next we verify 3. This is current node. In Then P is less than current node, so left. And Q is greater than current node, so right. Then split occurs, so the lowest common ancestor is 3. Okay. Let me clarify of time complexity and space complexity. Time complexity. We only verify mm, only one node every layers. So we only check this and this and this. We can only if. So time complexity is O, big O, height. Big O, height, time complexity. And how about space complexity? We don't have to use any data set and any data algorithm. So in this case, space complexity is a constant value. Okay, let's check the code. First, we have to set current value in the root node. And we can use while loop. Current is not null. First condition is both is greater than current node. So p dot value greater than current dot value and q dot value greater than current dot value. In this condition, we have to we can check next right node. So current is current right node. If p dot value less than current value and q dot value less than current value. In this case, next we have to check current left child. The last case, is split occur or we find P or Q. In this case, in this condition, return current value. That's it. Okay, let's check this code. Okay, good. Great. So if we, speaking of binary search tree, the greater is right, less is left. This condition is essential. And simple binary search tree, we doubt if we can use while loop. And single pointer to moving. Okay, thank you for watching. See you tomorrow.